before, so my plan is having some exercise for especially for the substitution. The important notes for this pattern is the first, maybe the first clue that you might do when you see the equation is, if the equation is homogeneous, we can start looking this or this, if it's homogeneous. Homogeneous is when you see the degree. It's supposed to be having the same degree. Okay? Remember, maybe we'll look at the notes, maybe this one. When we can prove this, that it has the same degree, and we can prove that, okay, it has the same multiplication of the degree, then we can say it's homogeneous function. Okay? So perhaps that's the very first thing if you see equations. Okay? So when you see the equation, maybe it's not or cannot be separable, cannot be separate, and it's not a linear differential equation, and perhaps it's supposed to be like exact equation, but it's not exact. You can do make sure that you can take the homogeneity. Okay? You can find whether it's homogeneous or not. Okay? Then you can follow up the substitution method. Or even if you can find that perhaps it is directly like having the Bernoulli equation like this. You have dy over dx, dxy, and then you have another function of x, and you have another y with maybe power of something, and you can think that, okay, probably this is a Bernoulli. So you can directly substitute. According to the order of the y. Okay? Well, for substitutions, any variable you need to substitute, actually it's up to you. Whatever variable you want, because that is just dummy variable. So at the end, you can revert back to the original variable. So either maybe in the process you need to substitute more than once. Perhaps it's also possible. Okay, maybe we go to I believe the last exercise we do is this, right? Okay, I hope you can try by own. Okay, this one. Try to separate, refreshing your integral techniques. Let me start with this. Okay, I think we can look up for this number 2. Yeah, I think we can start to substitute with this. So sub with this, and we get that. So when I try to take v as y squared, and my v prime is 2y y prime because of the chain rule. So I can exchange this to our y prime. Y squared is v. Okay, so let's do that. So we are going to have v prime plus 1 equal v plus x. And by doing so, we can separate. Then we can separate v and we can separate x. Okay, both sides have own variable. So we can have v prime minus v and x minus 1. And we can also treat this as, I think, a linear equation, okay? Or if you would like to write in terms of dv to make sure that we are on the same page, this is also okay. Remember that if we have the linear, we are going to have, let me write the original one here. This is plus pxy equal f of x, okay? So we have our p here, p of x is -1, right? And the f of x is x minus 1. So we can take the integrating factor. So so this will be e with power of -x. Okay, and then we can multiply. So multiply. So e with power -x. Okay. And then we can write the product form. This will be E and V. And you can check. I think it's correct. And this is, we can write. And then we can integrate both sides. This will be E power -x multiplied with V equal, well, you could take this integrations. This is x e -x minus e -x, right? And I think we could take integration by parts, right? We can integrate by parts. But since we have e to the power of -x, maybe we can start, because it's not really that difficult to derive. Maybe we start to derive it and see what happened, because e will be e, right? And I think if you remember your calculus correctly, when we derive this, we will have this pattern. Okay, we will have this pattern. Okay, so if we try to derive that, let's say we are going to derive this. This will be a product rule, right? So E plus negative, and we get the E negative x, right? So I think if we add negative in the front, then we get correctly, right? We get x so I think we need to have this, the functions will be negative x with power x. Okay, just my idea, my suggestion. If not, you can just integrate by parts. Should be still okay, But in my opinion, when you have e, I think you could try to look at the pattern, and maybe when you have like this one, the one that you have after integration will be around this function. So maybe with x, and maybe you need to derive this first and to look how it goes. And I think we get negative x with power of negative x. So we get here negative x e with power negative x. Don't forget to plus the constant. And since we have the initial value, where is my initial value? Oh, it's up there. Let me write again. Initial value is, and don't forget that we have v. V is what? V is y squared. V is y squared. So y squared, y is 1, y squared is 1, so p is 1, and 1, 0, 0, so get the c. So 0 is become 1, so 1 equal 0 plus c, or c is equal 1. Then we get e y squared equal negative x, e to the power negative x plus 1. Or if you would like, we can divide and becomes y squared negative x plus e power x. Or if you would like to make the square root, I think also okay. Okay. Yeah, sorry, it's a little bit messy, but I hope you get the direction. From here, here. Well, you could try also to recheck and reconfirm the calculation. I think we can set maybe 2 or 3 questions. Hopefully enough. If we need more, I think next Tuesday we can have a little bit more. But I need to move to the next section. I hope you don't mind. So to fulfill your practice this week, I will give you, I think, homework. Maybe this 4 questions. Maybe tomorrow. Yeah, tomorrow. Okay, I think we can start the. Wait. Okay. Okay. Um, solve the first one. Let me give you two equations. Okay, let's try. You have to be careful. And think a little bit long because of the structure. If you want to substitute, it's a homogeneous, so you can substitute either using ux or vy. I think if you are using ux, you are going to make this longer. So maybe it's not the best option. You need to try to cancel out and slowly finding the solution. Yeah, maybe later to change. Yeah, it's quite long. So actually, the first half of the lecture is around the differential. So the first order, the higher order, and actually it relies a lot on calculus. So yeah, some techniques in calculus, because the differentials, I think, not really that much. I mean the content. The rest of the difficulty is the calculus one, the calculus part. Techniques from calculus you need to bring on into the to solve this equation. And number two, the clue is check the structure. Check the structure, whether it's a linear or it's going to be like a Bernoulli. You can try to simplify first. So for the second question, you need to divide this and see. Well, probably you can imagine that this is probably a Bernoulli. So you could start write the Bernoulli, the structure, and then you need to match the structure and find the substitution, and then you can find after the substitution, every Bernoulli equation will end up with the linear equation. So you will use linear equations, integrating factor, and so on. Okay. So the first two methods that you need to master, at least for the first order, is the separable and linear. Because those two usually will be the very like when you play some games, like fighting games, it's like the finishing moves. So yeah, I think you need to master at least the separable and the linear. Yeah, I think if you stuck with number one, I think number two will be, I think, easier. I think easier to see this. Okay. I think I will give a clue for number one. Okay. So for number one, we could have substitute the x with phi y. Why we need to have this? Okay. Well, you can start with ux. If we start with ux for y equal ux, this ux and then dy will also be changed to ux, right? And we need to have more expansion. So I think it will be more destructive, right? It's not really helpful. So if we change this, I think it will be very, compared with the ux, we only have this expansion here. Okay? Dy's just stay as dy. So I think it will be easy to be carried, okay? This substitutions. Okay. Well, sometimes you can see both, and well, if there's no other choice, you need to check both, okay, both substitutions. Okay. So if we check this, then the x is phi dy plus y d phi. Okay. So we are going to exchange all. So y phi dy plus y d phi plus phi y ln phi y minus ln y minus 1, and then dy. I think we can simplify this, right? We can cancel this y. So it's ln v minus 1, and I think we can simplify the others as well. Now let me skip some part, and this will be y d phi. Yeah, we could cancel y, all y divided by y, right? So plus phi ln v dy. And this will be equal to 0. And from here we can also simplify. Let me move this part going down. We move and we separate this, becomes d phi ln phi plus dy over y equal to 0. And we can start to integrate. Now we have, I think it's quite unique here, phi ln phi. So it's like, remember that the derivative of the ln x is 1 over x. And it goes to have 1 over something. So probably start with ln and have some chain rule. And you get the ln phi like that. Right? You have, if we derive this, 1 over ln v, and ln v is 1 over v, so 1 over v ln v. Yeah, I'm not sure. In my calculus class, do I give you the like ln? No. Okay. That's my fault. Well, because we can have like x ln x, and then we can have x ln x ln x, and if we like ln is inside the ln, and when you take that, you will have ln. Okay, and the last part is ln y. And we could combine this together. I think we can move the ln out. So y and phi is x is phi y. So phi is x over y. So x over y. So we can cancel this ln out, and we say, and we can, or maybe we need to multiply first. Multiply here. So we will have ln y ln x over y. Or it's not equal 0, sorry, it should be constant, having a constant one. So we get, maybe right here, that y ln x over y becomes another constant. Okay, I remove the ln in the front. Okay, so it becomes another constant. So maybe here is y ln phi. This is still c1, and then I remove the ln, so it should be having another constant. So don't worry too much when you remove the ln and make should be e, right? Should be e power of something, but because it's also a constant, just change the constant. It's okay because we know how to connect them with the initial value. Okay. Initial value is e. So y. So we can connect this. E. So e ln 1 over e. So this is minus 1 e minus e, right? Okay. So we get the solutions is y ln equal minus e. But this is an implicit solution. But I think I will just skip this. Yeah, I think it really takes time. Okay, the second one. Anyone finish the second one? Okay, this is the Bernoulli equation. So first thing, we define or we make this dy by dx, so we divide all with the y power half. So we have this become y, and the right side becomes y with power of negative 1 over 2. Okay? So we get dy over dx plus y equal y negative 1 over 2. And we need to force out this equation to be linear. So we need to sub, and according to this, we need to sub with something that can not reduce, making this becomes linear. So let's say u is y 3 over 2. So du dx is 3 over 2 y half. And then dy dx. And then we obtain du over dx. From here, from this, we try to plug into our solution. And after some simplifications, we get this will be 3 over 2 u, okay, and then equal 3 over 2. And then from here, we take the linear differential equations, and it's the same as this equations. So px is 3 over 2, so we can take the integrating factor, e with power of 3 over 2 dx. So we have e 3 over 2 x, and then multiply, going back here again, so we will have e du dx plus 3 over 2 u e 3 over 2x, and then multiply with the three over 2 e power 3 over 2 x. And then solve as usual, and you get the equations, and then you need to get the constant from the initial value. Well, it's a little bit long, I think. But I think in your exam, you can have this calculator. Okay, so this is okay for you. At least to confirm your result, this is okay. Also, please bring your own A4, just one piece. So you will know what will we do with those A4 in the exam, in the quiz. I would like to give one more, but if we don't have much time, I will later continue in all of this in the Tuesday class. Okay. Let me give you the other question here. Okay. Because we haven't yet touched this example, kind of example. We have the cosine. Okay, so we have a trigonometric. It seems trigonometric, but it's supposed to be can be solved by the substitution method. But if we don't have much time, then we are maybe continue next Tuesday. So I think next Tuesday. Maybe another 2, and then some review what we will have in the quiz. The last hour maybe for an introduction for the next part. Yeah. The key components for the engineering of math is, aside the calculus technique, is I think the procedures you need to be really aware of your calculations. That's why I'm asking you to bring calculator so that you can at least confirm your result. Because of course I will check your writings. Okay, so for this part, we are actually substitute the x plus 1. And I think, because we only have a few minutes, no feedback quiz, I think. Okay? I will keep feedback quiz on Tuesday class. So for this one, let me just give you some intro to solve this. So x plus 1 we can substitute with variable. Okay? So it's a little bit long at the process, but I hope when you understand the first process, you can get through for the next part. I think we can move this. Let me copy and take this to another page. So we take the substitute the x plus y. Okay. So we are going to have du over dx is 1 plus dy over dx. So always we are having like a single variable calculus. We are not really doing in a partial way. So we are going to differentiate with respect to one variable only. Okay. In our case, this x. Okay. So we take this, and we get our dy over dx. So we can move to our solution here. or our proposed equations. So this is cosine u. But it's not done yet. We need to solve this. So first you need to I think you need to solve this. I think just multiply with dx. I think just multiply with dx. So du minus dx is cosine u dx. So you will have du dx 1 plus cosine u and 1 over 1 plus cosine u du equal to dx. Yeah, a little bit algebra to solve. I think 1 plus cosine u, we still not sure. Can we solve this? I think we can multiply and make it into 1 minus cosine squared. So we can multiply 1 minus cosine, 1 minus cosine. Hopefully we can find this 1 minus cosine squared will be sine squared. So at least we can simplify that, and maybe we can separate become some fractions, perhaps. So multiply with 1 minus cos u, I think. So we have 1 minus cos u over, it's sine squared, right? Sine squared u. And now I think we can integrate now. I think 1 over sine squared, one side, minus cosine over sine squared. This is going to be, so let me write here. So 1 over sine squared u, let me write du. We can integrate minus integrate cosine u over sine squared u du. I think we can integrate this, right? And I think we can also make this cosine sine we can write that. Cosecant, cotangent. But if you don't familiar, I think you can just integrate this using regular substitution. I think still okay. And this is equal to x plus c. Okay. Okay, I leave the final solution to you. I hope you get the idea. So yeah, probably the last technique is, I think, the most difficult one, the substitution. So yeah, I will give you some homework to help. Okay, thanks. See you next Tuesday. Please check Moodle. At least tomorrow, I will upload the some homework. Okay. I hope you can make some exercise.